Dan Perry here with another digital electronics tutorial for Dan on Tech. In this video we'll look at the voltage across series resistors and measuring it. I'm currently measuring the resistance across two resistors that are in series. I'm getting in the neighborhood of 470 ohms. And now I'm going to connect a couple of leads to the ground and to the plus voltage terminals. I've not got any voltage connected or any power connected, and I'm going to measure that voltage or that resistance again across the two resistors. And when I do, I'm coming up with about the same voltage. Again, I'm measuring across both resistors. Now I'm going to switch to the voltage setting, and I'm going to first, with nothing connected, measure the voltage across, and I'm not getting any voltage. Well, with no power source connected, I would not expect to get any voltage, and so you can see it's giving me about 0 volts. Now I'm going to connect my ground and my hot power, my hot lead, and I'll connect those into the circuit. Now I've got current flowing through the circuit and voltage across the circuit. When I measure now, you'll see I'll have voltage, and I've got a little over 7 volts. Okay, now I'll just pull those leads out of my way, and I'm going to measure, once again, I'm going to measure across both, and I'm getting, again, that approximately 4.7 volts. And that's across both resistors. That's the same voltage as coming out of my power supply. And now I'm going to measure the voltage across one of those two resistors. And when I measure, I'm getting, in this case, about 3.75 volts. And when I measure across the other, I'm going to get a little over 3.75 volts, a little bit more than that. And if you were to add those two voltages together, you're going to get approximately the voltage we had across both. Now, because I'm not getting a great connection in all cases with these leads, because of the way just trying to hold my leads across, there's a little bit of variation. It's not exact. Now, I have removed the power, and I've got measuring the resistance again across both, and then resistance across one of them, about 250 ohms, a little more. The other should be about the same. So both of these are around 250 ohm resistors. So what happened was you saw that the voltage across each was about half of the voltage. If the resistances were the same, they should both drop about half the voltage. And that's what we saw in this example. Now what we're going to do is replace one of those resistors with a resistor of a different value, and that's what we've done. And now if I measure the voltage across both resistors, I'm going to get about, in this case, about 8 volts it's showing. And then if I measure across one of the resistors, about a little over 6 of those volts on across one, and across the other resistor, once we can get a good connection, it's hard to, I'm trying to hold those leads so you can still see the meter. And here we get around 2. And again, I'm not getting a great connection with my leads because of the way I'm trying to hold it. But if you add those two voltages across each of those resistors, that should be approximately that total voltage. If I had a very accurate measurement, if I was getting a good connection, that would be exactly that. And now I'll look at the resistance across both, and I'm getting 800 and some ohms. One of those is about 650 ohms, and the other resistor is about 250 ohms. And if you go back and see how we calculate voltage across resistors in series from an earlier video, and you do the calculations, you'll find that that voltage division, that voltage divider across the two would be correct. The larger resistor drops the largest amount of voltage. Well, thank you for watching this Dan on Tech video. Please subscribe to this playlist so you don't miss future videos. Please check out and subscribe to our other playlists on the Dan on Tech channel.